I'm Alan Cox with Government Technology Magazine. You are in a section on storage. I hope this is the right room for you. If you're looking for open government, you're in the wrong room. So we have 4 presenters with us, 3 presentations, and then we're going to do some Q&A. I'm going to introduce all of the speakers. We have Michael Leitner-Young, who is a data center architect and now the senior data center architect for NetApp, here with us. Next to him is Eric Wisniewski, who is the sales engineering manager for Hawaii and Asia Pacific. He's been a collaborative cloud architect and technology leader as well. And then we have from the University of Hawaii, Steve Smith, who's the interim vice president for information technology and the university's chief information officer. Also, we have Roger Thoren. Roger comes to us from the airline industry, the banking industry, the insurance industry, and has now landed in government service. He is the manager of the database section within the Information Communication Service Division of the Department of Accounting and General Services at the state of Hawaii. So without further ado, I'll turn the podium over to Eric and Michael to get us started.
Thank you. So as you guys already heard, I'm from NetApp. I'm Michael Leitner. I'm the enterprise account engineer for the state of California as well as Hawaii. And Eric is with Worldwide Technologies. And we're here to give you guys a quick overview of storage trends in the markets, different technologies, and different things that our customers are using in order to mitigate their challenges in storage.
So from an agenda perspective, just at a high level, these are the 5 topics, summary level again, that we're going to cover during our presentation. IT challenges, which can be very in-depth, trend standards of storage, innovations and efficiencies of storage, the market, and where things have proven where they're going, and actually some best practices around managing the life cycle of storage. And of course, at the end, we want to reserve some time for you for Q&A.
So a lot of the challenges that IT, especially government IT, is budget and funding, right? Everyone realizes the budgets are getting tighter, funding is getting harder and harder to acquire, and quite frankly, the hardware is not really getting any cheaper. The people costs aren't going down. When we start talking about people, we also have to worry about an aging workforce, right? So if we look at the state of Washington, 50% of their IT staff is over the age of 50. 25% of the staff that's over 50 can retire at any moment, right? So this is a real problem for them, especially since the workforce around Washington with Microsoft there and all the other big corporations is expecting higher and higher pay wage when the state actually is not increasing pay wages. So for growth pressures, we see almost 800% is what Gartner is saying over the next 5 years of a growth in storage industries. Big data, unstructured data is getting bigger and bigger and bigger. You guys are going to hear more about that and how do we mitigate that with less budget? How do we mitigate that with less people overall?
So one of the things that's really key about storage outside of IT and the other silos from a data center perspective is an inflection point. And just when you look at storage in of itself and the data growth, the management of data growth by people and technologies that are actually moving quite quickly, there comes an inflection point where an organization, a department, or a government entity has to look at, can we continue doing what we're doing today, or do we need to actually transform, or do we need to look at improving our policies, our processes, our procedures, educating our people, training them, etc. So what happens is information becomes a propellant to business, where there's business alignment or mission alignment, and or data becomes a burden to IT infrastructure. So some of the customers that we work with, both in the government and outside the government, they still have Lotus 123 files, right, from 1980 on storage. Do they really need that file anymore? Was it last accessed in 1989? Can they move it over? So that's just a very small example of an inflection point of how are you managing your data? What are you going to do from a lifecycle perspective in managing the data you have today as well as the data that you're going to have 18, 36, 72 months later. All right, so some examples under where is my inflection point and what's the drivers or what's driving my information growth, my storage growth as well.
Yeah, these are really, really big drivers in the industry today, especially if you allow for unchecked growth, VMware sprawl. You guys are going to hit this inflection point much quicker than you can think.
One other thing I might add to this, and we don't have it on here, we might later in the deck, we're starting to see a lot of video surveillance out there, right? So where does all that stuff go? It's going to disk, it's going to storage, it's going to a frame somewhere, right? So how are we managing that, right? And then you have the mobility, BYOD, if you're looking into that or not looking into that. As you move things and centralize and converge even more so your data center and the data that's underlying it, and your depreciating assets in ERP or CRM or anything along those lines, or even applications that are proprietary within your organization, it's all going to be driving into, and certainly sooner or later, you're going to have an inflection point. So just be aware of that.
Okay. So, relentless growth, right? I just said 800% over the next 5 years. Maybe you're seeing something like that, maybe you're not. And my customers, Department of Justice, Department of Water, a lot of different agencies, we're seeing massive growth, 400%, some of them year over year. Everyone's collecting new types of data. We've decided that the Department of Correction wants to now take pictures of every inmate every 15 days to make sure that we're not beating them up or hurting them, right? Where does that data go? It has to go somewhere, okay? So these are trending numbers, and we actually are going to have a couple slides of actual customers that you guys can see over the course of time, their actual growth rate as they run storage. So think of this, whatever you have today, multiply it by 400, and think, where will I put that data in 4 years? Where will I put that data in 5 years? And better yet, how am I going to back that data up? Because backups get longer and longer and longer, especially as the data growth gets bigger and bigger and bigger.
This is a great example, as Michael was saying. City of Austin, the city of San Diego. If you just look at these two examples and you look at where were they in 09, right? And where are they today? Literally, where are they today in the percentage of SATA storage, their non-SATA storage in terabytes, etc. 9, 10, 11, 12, 13. Basically, you're looking at 5 years thus far in the growth in the city of San Diego as well as the city of Austin. And obviously there's technologies and there's business requirements and drivers behind the growth. But these are two very good examples of where they're going, and even some of them, they'll dip. Maybe they had a refresh or something along those lines. They moved all over to a new technology. They're actually looking at tiering their workloads to match up with the appropriate level of storage. But the real data point of this is it's growing. It continues to grow diagonally in scales.
Yeah, it's kind of like the stock market. Maybe they deleted a huge database, right? Great, there's a dip, but there's still data being generated. So as time goes on, it's just getting better and better and bigger and bigger. So when we talk to Gartner, and like a lot of larger companies, we pay Gartner to give us analytics and tell us where the trends are and where the future is, right? So what they see is storage as a service. They see a lot of centralized storage systems coming in. The IT department is now providing what they would call a service to their individual departments below them or within them, their peers. So they want it to be transparent, scalable, it needs to be efficient, has to support intelligent caching, ideally a unified architecture, because if you have customers who want to run an IP-based schema and another customer wants to run a fiber channel-based schema, you need to be able to provide that. You don't have to be buying new hardware and training new people and managing a whole bunch of different pieces. So this is the breakdown of what Gartner says, hey, you guys need to be looking at these options if you want to run your internal IT service as a service, not just a reactionary program. Hey, we have 10 terabytes, I need 10 terabytes for my SQL database. Well, put a request in, we'll have the service automation generate that for you, and you get your 10 terabytes.
Hold on a little bit.
Yeah.
I think one of the key points about this slide also, from my perspective, in my background in technology and engineering, 9 of those 10 data points on there. These are not cutting edge today. This is what's been out there for the last 10 years. Now, has it matured and has it gotten more and more rich or evolved? Absolutely. But when you look at 9, outside of the service automation analytics piece, these other 9 data points truly are what is a best or proven practice today. And a lot of this came really to an inflection point from a storage perspective and managing storage, I would say starting in 2004 from a business development perspective. That's where you see storage really kind of changing and the vendors changing their way. Today, these things are expected when you're looking at storage and managing your storage today.
In the next couple slides, we're going to go a little more detail as to what you guys should look for software and hardware-wise.
So, really quick, because I could speak to this for like 4 hours. Really what you're looking at is the maturity of how workloads and the supporting storage and the actual data sets are moving today. This is one of the trends that's, again, this trend is not cutting edge. It's not pushing the envelope. This is what's been transpiring. One-to-one relationships, one app to one server, application-based silos, LOBs or lines of business, right? Now they're going into a virtualized, converged infrastructure. That happened back in the early to mid-2000s. Now organizations, when you look at cloud per se, organizations are not jumping into public cloud. Over 90% are not going to public cloud, unless maybe they're doing a little bit of development here and there, UAT, Q&A, etc., QA I should say. What they're doing is they're building out their private cloud. This is a maturity step in the zones of virtualization of the private cloud where they're taking their storage and they're realizing, I don't need these disparate silos. I can actually take my data sets, if you will, in these silos, move them into a centralized storage environment with all those bits that we were just showing in the previous slide in a private cloud, and I can manage it holistically. I can dedupe, I can archive, I can tier and place my workloads at the correct level of storage and get efficiencies and cost drivers much faster, my return on expense, my return on investment, much quicker today by moving into that approach.
Yeah, so this is an example of a typical customer's entry into what we would throw up the quotations called cloud, right? When you think cloud, the reality of it is it's VMware, and it's running inside your data center, and the only thing that makes it a cloud is the fact that we like to make fancy buzzwords, okay? So when we're designing this solution, we need multi-tiered, because not everyone needs the highest application level. Oops, sorry. Not everyone needs the mid-grade, or not everyone needs the low end. So multi-tenancy allows us to take multiple applications and put them on the same physical hardware, but break it apart virtually, just like how you do today with VMware. So that's no different in a cloud sense than where you guys are right now. The only difference is we're doing it all the way down the stack. So we do it from the server level down to the storage level. That's what multi-tenancy gives you. It gives them their own storage, but virtually. So a customer says, hey, I want my silo. I want to maintain what I have. They can still do it, and they can still join your internal virtualization cloud and get their own management points. They can do all that for you. Then the next step is, okay, who is willing to actually let go of their data, let that data go to the actual cloud, and then I don't have to worry about backing it up anymore, because now it's no longer on my footprint. It's now up in Amazon or Microsoft or wherever you guys decide you want to put it. Those customers, those are what we would call the low-hanging fruit, right? And when we can start finding the hybrid between these two, it gives you guys a much more compelling solution for your end customer. You can say, hey, end customer, it's $1 per gigabyte if you want to run it on our cloud. It's 45 cents per gigabyte if you want to run it on their cloud. Here are the pros, here are the cons as listed, right? Here's the benefits, right? IT budgets. Obviously, those guys, Microsoft, they can do it a little bit cheaper, right? They have the infrastructure already in place. They don't have to buy anything. You guys will have to obviously scale up in order to support more and more customers as your internal cloud grows. Eric?
It's a perfect example. I think Michael's hitting the nail on the head here, where this just shows you not only the trends of what's transpiring today with organizations, but they're also showing you this is what's been going on in a healthy manner over the last 7 to 8 years, where organizations, government entities realize, especially in the DoD work that we do, they can't afford to do all this individual siloed approach anymore. They have to actually get into this multi-tenant, secure multi-tenant approach where the workloads can still run across the different levels of hardware, but they have a storage subsystem that's associated with their workloads. It's aligned correctly, and they're also looking at all the value that they're getting out of it, right? All the efficiencies, the DR, the business continuity, or the continuation of operations, replication, etc. So this is a great slide that just shows at a high level. This is what's transpiring with probably 65 to 75% of the world today.
Yep.
And actually, we're in the States, we're kind of a lagger compared to how they are over in Europe, actually. So
real quick, I would note, the Department of Water, this was our original design for their internal cloud. They said, hey, we want to be able to be multi-tenant. The way the state of California works is they have the Department of Water, Fish and Game, Parks and Rec, and all these other departments under them. Each one had their own storage, and each one had their own storage budget, as well as their own IT budget. Department of Water said, hey, we want to nix all that. We want to be the cloud provider for everyone. And this is exactly what they've done. They've taken physical hardware, multiple servers, and they've split it up. So the Department of Fish and Game, they get their own silo. And this is where the future ultimately will be. As budgets get tighter and tighter, shared resources are going to be necessary.
I think one last thing I want to say, I'll give you a real world example. It's not up here. So back in 2008, I worked in the UK quite extensively, and the ministries in Europe, the European Union, right? All these disparate ministries, Ministry of Defense, Intelligence, etc. They're all right there, the app and work silos. Well, CIO at a very high level came down and said all the ministries have to go to a private cloud, and they have 3 years to do it. So every ministry now in Europe actually has their own private cloud, where they have this approach now. They don't outsource anything, but they have a secure multi-tenant environment where today, it took them years to get there, but now they do self-provisioning, and they have life cycles and everything around their data sets on their storage, and allows them to scale diagonally to meet their needs. So that's stuff that was done in 2008 over in the UK, where organizations are still trying to get their feet wet here in the States from a governmental standpoint.
Okay, so once again, we pay IDC and we pay Gartner, these guys, to give us good information. And some of the information that they give us, and this is pretty interesting, is storage is 23% of the total budget of an IT department. So when you start looking at the line items, where is my dollars going to? Servers and storage make up the lion's share. So this session is about how do we mitigate that cost? How do we get more out of what we're spending, right? So we talked about multi-tenancy, we talked about sharing the resource. The next phase of this is going to be, what is the software underlining it? What is the hardware underlining getting there? So unified, having a unified portfolio will help you guys with that cost standpoint. If I don't have to go out and purchase, once again, a fiber channel array because my end user wanted IP-based, we now have one management point, so there's an employee management issue there, right? We don't have to learn another device. We don't have to patch another device. And we can add additional storage to the current unified structure that we have. These are the common protocols in the industry today. So the more of these we can hit with our devices, the more likely we are to be able to say, yes, end user, I can accept your data, and I will be charge back or get back to you. The second thing is being able to leverage SSD drives, caching, and SATA drives to be able to maximize our total storage footprint while minimizing the overall cost. So one thing that a lot of companies are doing is tiering, right? So you guys probably all heard of that. Using SATA drive with SSD drives or SSD cache in front of it. We can get a lot better performance out of these systems. So we're spending for the cheap disk, but getting the fast disk speed, which is what we want. And lastly, the technology behind it. Snapshots, cloning, compression, and deduplication. Deduplication on an average customer base, we're actually going to show you guys, saves anywhere up to 90%, depending on what the workload is, depending on the type of data. And we're not talking about deduplication on the backups. We're talking about deduplication on the primary data. This is a big, big trend, and a lot of vendors are moving towards it. So it's not just a NetApp thing. Compression. Once again, with deduplication, you add those two together, you're going to get a lot more savings. And cloning, it doesn't, the name of, I would say, is thin provision cloning, right? So taking a piece of data that's 10 terabytes, cloning it out and only using a couple hundred names. When you got your DBAs who always want 1,000 clones of everything, right? We want to be able to clone those out quickly, efficiently, without having to take up a whole bunch of additional space.
That's good.
Yep. Okay.
So I think really here, when you address data growth, right? You're going from small to large, the volume, the data sets themselves. There's an immediate response that's required, but the simple, consistent management, right, of that subsystem, or actually that storage environment, is key. What Michael was saying earlier, consistent management, unified or single pane of glass to manage all of that subsystem is very important, that unified architecture. And the reality is this. You always hear about scale out and you hear scale up. But the best practice, the proven practice, is to scale diagonally, right? So you're not only able to meet capacity and demand requirements, but you're able to continue with that ease of management and the operational benefits of where you're not creating new standards and you're not having to reinvent the wheel. You're able to add on storage, you're able to manage it efficiently from an operational perspective, and you're able to actually meet the demand that's placed upon you from DBAs, new projects, recovery, etc. So these are very, very important data points just on that diagonal approach.
So there's some different key factors here, right? When we start talking about software levels, and this kind of goes back to the previous slide I was talking about. So if you just leave data uncontrolled 800% over the next 5 years, we already discussed that, IDC says it, you guys can argue with me, any question, but realistically it's growing. SATA drives help us mitigate that. SATA plus caching mitigates it even more. Snapshot technology will help you guys with the DBAs and all the other folks who want multiple copies of that data. Thin provisioning has been around for a long, long time. It's been around since the 90s, right? But a lot of customers are afraid of it. They don't want to use it. It scares them. Hey, if I over-provision my storage, what happens if someone uses what they're not supposed to use? So that can be sometimes questionable, but it's something that we try to push a lot. Cloning, deduplication, compression, and then the final item is intelligent caching. It requires all of these to really mitigate storage heavily. If you use just one of them, you're not going to get a huge amount of savings right off the bat. If you use the vast majority of them, you will see a large decline in total data usage.
I think some of the good things that Mike was bringing up here, when you look at, as I did earlier, when you talk about dedupe and compression, right? Years ago, that was the big driver, the big win when you're looking at backups or restores, right? Well, now today, when you have those files, someone creates a file, it hasn't been changed, or if it doesn't make one change, it's compressed, and then the only delta, the only difference is just the marker of that change. You're not having to redo that entire data set for DBAs and other people into that. So you can actually mix and match these different feature sets based on your strategies. If it's around tiering of workloads, placement of workloads, tiering them through a life cycle, and then maybe putting them to tape, those data sets, and putting them off-site for recovery. There's so many different ways, but at the end of the day, that is a complete portfolio that you should be looking for in order to manage your storage environment holistically today.
So this is what we would what we like to look at is if you use these technologies, what kind of savings do you get with each one, right? So RAID 6, we can see quite a bit of savings by using RAID 6, but we take a performance penalty for that. So keep that in mind. Not everything needs to be high performance, right? Some things can run on RAID 6. Thin provisioning. Once again, sometimes scary for folks, sometimes not. Depends on if you know your workload and you know your end users. Deduplication will always be a big savings. There's no way around it. You guys are going to have duplicate data. Someone's going to take that Word document, change 5 letters in it, and resave it. If you don't have deduplication, you just save the whole Word document again. With it, you only save 5 letters. Snapshot copies, very powerful. If you guys aren't used to taking snapshots today, let's have a discussion about why you should be using snapshots and how you can leverage snapshots to mitigate backup windows and backup time and total numbers of disk drives you need for backup. Then replication. So being able to take small pieces and replicate them. So some of these older systems, they replicate all the data every night, which can take 12, 24, 60, who knows how many hours that takes. Look for solutions that allow you to replicate only the small changes, those 4K blocks or small block changes. And virtual clones, being able to take a snapshot, mount it, and be able to write to it and read from it for those database guys that need it. So this is the Department of Finance, and this is a quick snapshot, if you will, of what they're using from a space allocation standpoint. Total efficiency, and you can't really see it, the slide doesn't show that well, but they actually purchased a little under 400 gigabytes worth of, 400 terabytes worth of data. Leveraging the technologies that we've been talking about today, their actual efficiency is up into almost a petabyte. It's like a little over 800 terabytes. So a big portion of that comes from snapshot technologies and deduplication. These are the actual numbers right here. So 66 terabytes through deduplication, which, keep in mind guys, how much are you paying right now per terabyte? Does anyone know? Pretty expensive. Look at the cost, and then think back at 66 terabytes saved. Okay? Thin provisioning, 202 terabytes saved. Once again, how much money am I spending? How much money am I saving? Snapshot technology, this number, to be fair, is a little markety, so I'll break it down for you. If we were to do one full backup, we would save 195 terabytes. If we were to consider that every snapshot was a full backup, we would save 644 terabytes. So that's where you get that variable number, okay? Because a snapshot to this customer is a full backup that's then replicated to another array. Grand total savings, I believe, yeah, it's 497 terabytes on the low end, or almost a full petabyte on the high end. Once again, think about how much you're paying right now per terabyte, and think about how much these guys are saving.
And when you look at that last piece down here, that storage asset utilization, 213%. You can actually look at that as kind of a return on your investment, right?
Yeah.
You're not hitting 100% return on investment. You're over 210% because you're using those pieces of functionality, you're using those feature sets in order to get the most value out of your storage investment.
Let me ask you guys a question. When you guys go shop for a storage vendor, how many of you guys say, I want to know what the usable capacity is? Anyone? Raw? Did you guys shop by raw or usable? Well, guess what? This number is based on raw. So these guys are getting 213% above what they purchased from a raw capacity. Yeah.
Here's a good example. Arizona Economic Security, 10,000, 10K employees, right? 4.5 billion annually. 700 physical servers, 400 of them are virtualized, 30 to 40 servers per blade, virtual machines, if you will, per blade. 30-to-1 storage consolidation. That's a very, very good ratio. They reduce rack space, so if you're in other drivers and other things that you want to look at, if you're in the data center, you know, most organizations don't want to go build another data center, right? They want to actually consolidate, they want to reduce their real estate, they reduce their footprint, right? Reduce the rack space by 93%. 93%. That is huge. They're consuming less than 50% of that system, their data, and they're fully converged. Private cloud, and chargeback, and the workloads, the bursting capability, and load balancing, all-being, that's very mature stuff there. But if you just look at the private cloud from a storage perspective, and what they've been able to do, I mean, 10,000 employees, that is great. That is great. Those achievements are outstanding for an organization.
So once again, right, the question is, is what you have today, is your infrastructure good enough, right? When will you hit that inflection point? Think about it. Think about what we talked about today. Take that back, internalize it. And we're running a little short on time, so I want to thank you guys for letting us come up here and talk to you guys. If you have any questions, I think we're going to wait till the panel time. And Roger or Steve, you're up.
Thank you very much.
This is yours, correct, Steve?
Yeah, there you go.
All right, it's all yours.
Well, I think in retrospect, we probably should have changed the order because you guys went into a fair amount of a deep dive there on stuff that they're going to do. I'm going to do kind of a flyby on security, which then would lead logically to these guys who will give you some of the solutions for it. I'm going to talk primarily from storage needs that I do from my perspective at the university and in higher education and research. But that has relevance to government, it has relevance to business, because a lot of the challenges that we're facing today at a research university in storage, in processing, in networking, in the whole gamut of IT problems are the things that are going to become commoditized tomorrow and are going to be the things that folks use. So the storage challenges that we have, I can break down into three basic areas, and I think they're similar challenges that we all have in storage. One is security. And as we have larger and larger amounts of data and we're throwing it into storage and it's easier to store everything, and we capture more and more stuff from 1 million mobile devices, as we open up our interactions and put everything online, who's going to have access to that, and who appropriately should have access to that? And how do we set up the authentication and the authorization to have access to that? And particularly across multiple departments, in whether it's state government or it's universities. I just came from the Supercomputing 2013 conference, where we collaborate across institutions, across companies on projects, and we want to open up that data to folks. How do we authorize who gets into that and who can see that and at what levels? We need to make things safe but accessible. At the university, if we add in our students and our faculty and our staff and our researchers, we've got about 70,000 people that we need to provide access to everything to. And those students, that's 60,000 of them, there's churn in that, and they churn over every 3 months, and we've got new folks coming in. And how do we handle that so that we keep that access equitable for everybody? The biggest problem we have is you got multiple systems where you're storing stuff, and I can get access to it if I'm on this campus, but I don't have access if I'm on that campus. And how do we make that work better? The third problem is, and I threw it under security, but it's compliance. And I just gave a few of the acronyms there that we have to comply with there in terms of keeping that storage safe, but again accessible. And the compliance makes it more and more complicated. I don't know about you all, but we spend at the university a larger and larger amount of our workday just making sure that we're compliant with things. And then when we're spending all of our time with the compliance, if we go back to our keynote speaker this morning, we pretty much can get lost looking at the trees and we don't see the forest out there and what we're trying to do. The business we're in at the university is a free flow of communication. And if we spend all of our time focusing on compliance, all we're doing is looking at obstacles there. Second thing is, not all storage is equal. And this is something particularly you have to be careful of when you go out on the marketplace for that. What works for business and a lot of what may be doing in government would have an aspect of that, of what works in business. Doesn't work for the big data research. But government also has big data research as you get into geographic information systems. As you're storing larger and larger amounts, you have to be careful. Not all storage is equal. And you also have to be careful then as you go out and you're putting this stuff into the cloud, or you're working with the various vendors, that you don't run down that same proprietary dead end that we always run into. I mentioned I was just at the supercomputing conference. I sat down and had a meeting with the folks from Cray who were trying to sell me a better mousetrap for the university. One of the things they said was, you know, we have this system. We know you collaborate with other universities around the country. If we have a storage here that will work seamlessly so that you in Hawaii can collaborate with the folks in Washington State or California or Maryland or take your pick. But then I said, well, does that work if the folks that I'm collaborating with aren't using Cray? Well, no, you all have to use Cray. And right there, you're into the proprietary trap. The last thing is that big storage needs big bandwidth. As we increasingly get into this, particularly as you're going to do some transactions, particularly as you're going to do transfers, it's not just the storage device that you got, but it's the end-to-end. You're going to need big bandwidth to connect up these places where you got the storage with the access points, with the processing that you have. It's end-to-end. Within the university, we spend a whole lot of time working on what we call cyber infrastructure. That's the current cat's meow buzzword at the National Science Foundation and other research places. Cyber infrastructure. It's the end-to-end, and so you need to look at all of those. I said that in research, we have some different needs in business. Let me just give you one example of that. Our Pan-STARRS telescope system that is on Mauna Kea, and Pan-STARRS, I hate acronyms, that stands for Panoramic Survey Telescope and Rapid Response System, which is why we call it Pan-STARRS, because the other part is a mouthful. But we're putting up, in this 2014, a second iteration of that. That's going to generate 3 terabytes a night as it scans the skies. That's what it grabs in the data. But when we process that, when we actually turn it into usable information, you multiply that by a factor of 10. That's 30 terabytes a night. In a month, think how much we're going to need for storage for that baby. In a year, we're into petabytes that we're trying to store there. And this goes on repetitively, every day, every month, every year. And this is just one example, one telescope system of the many telescope systems that are out there. And this is only the ones that are looking at the sky. You've got the sensor networks that are in the ocean. Now this is for the university, and again, what happens is as we resolve these problems for storage, there are going to be issues that also are going to be applicable to the things that many of you may work with, whether you're in the Department of Transportation, whether you're doing something with health records, images for health, all of these things come together. We're putting together at the university in a new data center that's going to open in about a month, a high-performance computing condominium. It's probably going to have about a 100 teraflop cluster, and that is going to connect to other high-performance computing clusters around the country. And that is how we're going to weave all of this together so that we can handle that large amount of data that comes from the Pan-STARRS system or comes from some of these other systems that we're putting together. The condominium, and you guys before me went into some of that, really is a concept that works very well for storage, as well as for processing. But that whole condominium image is you have essentially, if you take that concept, a building with some common areas for storage. And the way that this works for us is different research projects are going to have different needs that are going to change. but we have that common infrastructure so that what somebody needed this month is going to change what they needed this year. Next year, they won't need as much, but we open that up so that other folks can use it. From an economic standpoint, the condominium makes a lot of sense. You've got to share that. If you build up separate silos for storage, that's just not going to become affordable for you. It doesn't mean that you might not have some local storage there, but you want to weave these together. So as I mentioned, we're working with a number of other institutions, a number of other options for storage so that we can share that storage, so that we can share some of that processing out there. I think there's about 3 basic kinds of storage needs that we look at. One is the temporary stuff. That's your scratch storage. That's the stuff that you take and you put it there, but you only need it for a brief period of time, maybe a week, maybe a month, and then it's reusable and you write over that, and it's just a place there's a holding area for it. The second one is that processor intensive stuff. That's the stuff where we got to take those 3 terabytes of nightly telescope data, and we've got to process that into something that's actually going to be meaningful and make that available to folks. That becomes a critical factor as you're trying to figure out how you pay for your storage. You know, a lot of these places, Amazon and some of the other cloud providers, got some good deals for storage and it looks real cheap, but you got to look at the fine print there in that agreement. Because quite often you can store stuff incredibly cheap, but then every time you touch it, every time there's a read, every time there's a write, ka-ching, there's another charge for that. And if you're doing a lot of processor intensive stuff, you're going to really raise the cost. You know, some of these things that you do with that is kind of like giving your kid a credit card. Say, use it wisely, and they begin to use it, and they say, oh, well, this is pretty good. I can do this, and it doesn't really feel bad. It's only fractions of a cent for storage. It's only fractions of a cent every time I access that data. But then you get the bill at the end of the month, and it's a whopper. So you have to be very careful with that. The third area, finally, that we get to is the archival. And that's storage so that we can have all of that data that's there and available, not just tomorrow, but next year and in 5 years from now. And the scale really starts to go up significantly. You saw that on some of the graphs from our first presentation there. And one of the things I haven't touched on here that we're really not discussing is the fact that a lot of this is not just storing the stuff, but how you manage that data, how you're going to have access to it, what kind of curation you're going to have so it's actually meaningful. And for all of us in the public sector, that really becomes the critical question, is who's going to be able to access that and with what ease. I mentioned that big storage needs big bandwidth. Here's just a few figures to emphasize that point. The time to copy 1 terabyte, if you're on a 10 meg network, that's about 300 hours, 12 and a half days. 100 meg, 30 hours. Well, you can see how this goes down. If you get to a 10 gig network, then it's about 20 minutes. Of course, the other piece in this, and this goes back to the cyber infrastructure I talked about with end-to-end. If you're going to be doing something on a 10 gig, you got to make sure that you also are going to have fast disks and fast file systems, or the whole thing is going to come and slow down tremendously. End-to-end, you're only as good as the weakest link that's in the chain there. So you need that big bandwidth in order to handle those enormous file transfer sizes. Now, we deal with this daily at the university. We've got these large files that we have to deal with for processing. You may think, well, yeah, but you guys are special doing the research. We're not going to need that now. You may not need it today, but you're going to need it tomorrow. You're going to need it next year. It's coming. And so you have to pay attention to the entire ecosystem that you're dealing with. It's not just finding a big whopping place to stick a bunch of data. It's how can I access that and do that in a timely fashion. So if your network becomes the choke point for that, it doesn't matter that you've got cheap, fast storage. That's not going to help you when you've got to get access to it. And of course, there's a lot of other traffic that's going on with this, and so these figures that I put together here is assuming that there's other traffic and other things that's going on with that network at the same time. So how are we handling some of these storage challenges at the university, and what are we doing? Well, starting with the network that I just talked about, and the fact that you need a fast network and a big bandwidth for big storage, we got 10 gig that connects all 10 of our campuses together. We got a couple of 10 gig circuits that connect us to the mainland, and we're upping those to about 40 gig. And the direction that everything's going, when I just came from the supercomputing conference, people aren't talking about 10 or 40, they're talking about 100 gig networks now. The backbone national research and education network in the country is a 100 gigabit or 100 gigabyte network. And that's where we're going to get to. Now, we're not using all of this bandwidth right now, admittedly. But as we move into this, you've got to have that infrastructure in place in order to handle it. And, again, it's the end-to-end. We got 10 gig that's going into each one of our 10 campuses. But you know what? That doesn't do the researcher that's sitting over in this building over here any advantage at all if he can't make use of that 10 gig and he's got a 100 meg connection that connects him up to it. So one of the other things that we're doing is we're connecting up on the Manoa campus here, which is where the primary research of the university takes place. We're putting 10 gig backbone in that goes out to all of those buildings where they're doing a lot of that work. You got to look at this whole thing end to end for that storage. I mentioned we've got a new data center that we're opening up in about a month. All of those buildings come back in and home in to that data center so that they can have that big bandwidth for that big storage that they need. Also, I mentioned about security at the beginning of this and the importance of that. But the other thing with that, and again it goes back to the weakest link in the chain, if you put in a lot of security there, and a lot of that goes into some of that compliance stuff that you got to do, or it's got to go in to make sure that personally identifiable information is not going to be inappropriately accessed. So what's the thing that we usually do with that? Let's throw in a firewall. Every time you got to go through a piece of hardware to get to the data that you want, you slow things down. You know, we ran into a problem when we were doing that. We were setting up these 10 gig circuits, and our researchers were saying, well, I'm not getting that kind of throughput, I'm not getting very good response. Well, of course not. We went back, we had our firewall set up with a hard ceiling of 1 gig. Well, that's not going to get you there. So we developed some other things on that. We put appliances in there that are going to allow a freer flow of that. We're putting in the Palo Alto system right now at the university to monitor that and to act as our security. And then we're setting up for our research network what we call a research network DMZ. And here's where networks, storage, the whole ecosystem again is not equal. Our administrative systems where we've got some records that we really want to hold tightly, that works in one area. But when you've got access to this research data, and I go back to the pan-stars things I showed you guys about, this collecting all that data from the stars, we set up a DMZ that bypasses all of these other security pieces that we've got in there so that you have a free flow, so that you can use more of that capacity of those 10 gig circuits. And again, the same thing is applicable to the public sector with government. As you're collecting lots of data, and Sonny talks about open government and open access to our data, as you're going to have those enormous data sets, you may have to think about something that's similar to our research network DMZ that's a government DMZ, so that people can have access to that stuff, and you just selectively choose the stuff that you're really going to make secure and you're going to have behind those multiple firewalls. Compliance. A lot of the stuff that we do is paid for with federal dollars. Federal dollars say you're going to store this stuff on U.S. soil and you cannot store it on foreign soil. We have to be very careful with that. A lot of the cloud offerings that are out there now, and this is the strength of the cloud, but it's also the downside of the cloud. They store it in servers all over the world. It's not necessarily going to be on U.S. soil. That's why we work with these projects like the Condo of Condos with other U.S. universities so that we can share those things. So essentially we've got, and you guys were mentioning this several times, a private cloud or a hybrid cloud so that we can ensure that we're going to stay compliant with things. I mentioned that there's storage is not always equal on what you need with some of the big data as opposed to what maybe business needs. We're trying to tier that at the university so that we have storage to meet every need. We don't have to go out and spend a lot of bucks on SATA storage for every need if you're just doing some documents and doing some collaborative stuff. So the university has gone to the cloud for its primary utilities for messaging and for simple storage, and then we're Google. It's Google Apps for Education. And part of that is Google Documents, they now call it Google Drives available. And our faculty, staff, students, anybody that's affiliated with the university can use the Google Drive. You get 25 gig that you can store on that. Immediately, that has answered a lot of our everyday business storage needs. On average, I just checked the numbers as I put this together, about 330 megabytes per user is what people in the university are storing. That's a lot of storage if you multiply that by the 70,000 people that are using our Google system there. So you look at some of those solutions, that's a low-cost solution for us to handle a lot of everyday. Then we do the local storage for our fast processing. And that's going to be in our IT center. For archival stuff, we're examining where we can come on the cloud because that doesn't have to have as fast access. And then we do the collaborative cloud that I mentioned, and that's our Condo of Condos. And we look at opportunities there. Net Plus is a program that's offered through Internet 2. Internet 2 is the next generation internet that about 200 research universities, including Hawaii, are members of. But what they have there is also available to the larger education and research communities. So that's available to K-12, it's available to other post-secondary institutions, and if you're a government agency and you're involved in research, that would also be available. So that provides low-cost cloud services, including storage. So briefly, those are the challenges we're facing, and those are some of the solutions we're looking at the university.
It always humbles me a bit when I think about the 512K floppy disks that I used to sell to the state of California in '86 and '87, and we were so excited to go to 1.4 megabyte, 3.5-inch disk format. Times have definitely changed. All right, I think we can turn the podium over to you, Roger.
It's interesting, when I was asked to be on this panel, I kind of was hesitant because I didn't know what I could offer. So I talked to some of my coworkers and we were looking at it in terms of, even though I'm a database administrator and in my section we also manage TSM, I could bring more of a consumer, a user perspective to storage. Rather than, what storage is out there. I know what we're doing with the tier 1 and tier 2. When Sunny was Goni was talking about they're creating their own private cloud. I know what they're doing because I'm on that IIS team. But it was really interesting to talk to everybody and get all that information. And I think these other presenters on the panel have also touched a lot of things that I'm going to be talking about too, which is it's interesting that even as a consumer, the same challenges run to us that we have to deal with. In my nearly, and I'm dating myself, nearly 40 years of IT experience as a consumer of storage, I've seen a lot of changes. with each iteration, storage has gotten faster, it's gotten cheaper, it's been more reliable, and the capacity has grown. Now, by that same token, as the capacity is growing, we need to consume more. And that's where, like I said, we're not talking about 1.44 megabytes of storage or 512 anymore of megabytes. We're talking about multiple hundreds and thousands of terabytes of storage we're consuming. In fact, when I first started, we had a computer room that was probably about twice the size of this room right here, and it was just full of disk arrays, and it was the type where you open the door up and you put the cover on it and you spin it and you lift the plate out and you put another disk array in and you spin that and you start it up, and when it failed you hear the whole room scream because the head just crashed against the plates and you had to run over there and power it down before it just totally destroyed everything on the drive. So it's amazing how now all that storage could fit on a thumb drive, which is amazing. And airline industries, they have thousands and thousands and thousands, tens of thousands of passenger records they have to deal with and all that type of stuff. Banks, obviously, they have all the information about their accounts. Within the government, we have information about not only the public, but we have information about our staffing too that we have to maintain. And all that's stored in databases. And then we have to have all of our budgetary information and all that's stored in databases. And a lot of this information is duplicated. And that's where we're going to have to do some more consolidation in that. And that's part of the objectives that the OIMT's team is working on. We've progressed along the way from paper to analog to digital storage. We're moving from a more mainframe-based environment to a server-based environment. Some of our issues have remained the same. I see some of you smiling. I didn't put up paper tape, which is where I started out, by the way. We're always wanting more storage. It's a constant thing. We have to deal with big data. We have to deal with paperless processing. We have to deal with preserving records forever. Bureau companions, they can't ever get rid of any of their data, period. Now we're getting more and more to the digital archiving. I know the State Archives is putting together a program where they're going to be archiving all of the important information. You go to Washington State, you see the former governor's website. They still have it. It's not the first one you hit, but you get to it, and you can see all of the information that the former governor put up there, all the documents they published. So it's important to retain our history. As they said, the growth of storage is really accelerating. I mean, with all of this type of information we're putting out there, there's never been a greater demand for our storage. Some of the issues are relatively new, like private and public cloud computing. The state is into both right now. We are putting together the private cloud, and we don't have the hardware in place yet, but we're in the process of procuring it. We're going to have a air gap between the tier 1 and tier 2, and on the tier 1 they're going to have a bunch of X blades in there. On the tier 2 they're going to have P nodes as well as X blades, and they're talking about the V7000 storage of having a relatively small amount, 100 terabytes for the tier 2 and 75 terabytes I think it was for the tier 1. We're also getting into data encryption and PII data security, which obviously is critical. I mean, I deal with some databases where they still dealing with things the old school way. Well, we'll just take our production database, which has all this PII data, and we'll make it our test database. And I cringe when I hear that, but you can't stop them. You can't tell them, no, you can't do what you want to do with your data, but you have to make sure you put in the controls to prevent that data from getting out and having it compromised. Our data has to be accessed 24/7 from any device. We're also doing mirroring of data. we're going to be, as part of our direction, we're going to be setting up multiple sites. I mean, some of you might have heard that Sonny's original vision, and I think it's still the vision, is he wants to have 5 data centers, 2 on Oahu, 1 on the 3 major island groups. That data is going to be replicated across to the different data centers that are going to be there, so that they are able to come up and not only balance the load, but also take over if there's a disaster in one of the data centers. I know Dave Fujimoto, who is our TSP expert for networking, he has been putting in this very large network that he's trying to set up all the duplication and make sure we have multiple access to multiple internet service providers, so that we don't have a situation where we lose our connectivity.